JEE mains. I hope that all of you will find it very useful. In this class, we are basically going to look at around 12 questions. Most of the questions, the first part will be on determinants and matrices. In every slot for JEE, at least 1 to 2 questions can be expected from this topic. We'll be looking at 5 questions. Basically, we'll be looking at 3 linear equations. And when this system of linear equations has no solution, unique solution or infinite solutions, we'll be discussing that in detail. There are 5 questions in this particular topic. That will be what we'll cover. And the second one will be on number systems. Number systems, basically we'll be looking at what is the remainder when a particular power is divided by another power. And I think there are around 6 to 7 questions on this. These are the 2 topics we'll be looking at today. Let us get started. Before we start, I wanted to tell you that we are giving 3 free mocks. All of them are in the latest pattern. These mocks are available completely for free and they're being taken by hundreds of students on a daily basis. You can check it out. The link for them is given in the description of this video, or you can just Google search Cracku JEE mains mocks. You either just Google search Cracku JEE mains mocks, or you can just go to the link that is given in the description of this video. You will be getting access to 3 free JEE mains mocks. All of them are in the latest pattern with very good explanations. I think they'll be very useful for you. Let us get started, and this is the first question that is there on your screen. A system of linear equations is given. We are told that this system of linear equations has no solution, and we are required to calculate the value of alpha. You have around 1.5 minutes. Try to solve it. After that, I'll give the explanation for it. Okay, let us try to solve this question. In this question, we are given 3 equations. So whenever you are given 3 equations which are of the form, say a1x plus b1y plus c1z is equal to d1, and a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. If say these are the 3 equations that are given, this system of linear equations will have either a unique solution, or it will have infinite solutions, or it will have no solutions. How can we figure out which of these 3 cases is possible? Let us first look at the first delta. This determinant is basically the matrix which contains a1, b1, c1, that is the coefficients of x, y and z, a2, b2, c2, a3, b3 and c3. If this determinant d is not equal to 0, the system has a unique solution. There will be exactly one value of x, y and z for which this system is actually satisfied. What will happen if d is 0? If d is 0, there are 2 cases possible. Either the system has infinite solutions, or the system has no solution. When the system has no solution, it is called an inconsistent system. When does the system have infinite solutions? For that, let us look at 3 more matrices called d1, d2 and d3. If d1, d2 and d3 are all equal to 0, this system has infinite solutions. If at least one of d1, d2 or d3 is not equal to 0, then this system has no solution. It is an inconsistent solution. Now what is D1? For D1, instead of A1, A2, A3 in this matrix, you just substitute D1, D2 and D3. For example, D1 will be small d1, small d2, small d3, b1, c1. The remaining two columns will be the same, b2, c2 and b3, c3. These two are the same. This is the determinant d1. What about d2? D2 is exactly the same as the original matrix D, except that other than B1, B2, B3, we'll be substituting D1, D2, D3. That is, it will look something like this. It will be A1, A2, A3. We have D1, D2, D3. We have C1, C2 and C3. This is the second matrix D2. And what about D3? D3 is exactly the same as D. We have A1, B1. At least the first two columns will be the same, A3, B3. And the third column will be, instead of C1, C2 and C3, it will be D1, D2 and D3. So again, coming back to it, once you are given this system of linear equations, first calculate the value of D. D is the determinant of the 3 by 3 matrix, which consists of the coefficients of X, Y and Z. So that is A1, A2, A3, B1, B2, B3, C1, C2, C3. If this determinant is not equal to 0, this system will have a unique solution. If this determinant is equal to 0, there are two cases possible. Either the system has infinite solutions or no solution. When does the system have infinite solutions? It will have infinite solutions if all the three determinants D1, D2 and D3 are all equal to 0. If at least one of D1, D2 and D3 is not equal to 0, the system will have no solution. And these are the values of D1, D2 and D3. Now coming to this particular question. We are told that this system has no solution. If this system has no solution, the first condition that should be followed is that the determinant D has to be equal to 0. What is D? D will be, this is 3, 1, 4. Then we have 2, alpha, minus 1 and 1, 2 and 1. This determinant has to be equal to 0. This is equal to 3 times alpha plus 2 minus 1 into 2 into 1 plus 1, 3 plus 4 into 4 minus alpha. This has to be equal to 0. This is the first condition that is needed for the system to have no solution. If you are simplifying it, this is 3 alpha plus 6 minus 3 plus 16 minus 4 alpha is equal to 0. This is alpha is equal to 19. So the value of alpha has to be equal to 19. Let us now look at the next question. Rajesh is saying, sir, how to manage time in different sections in JEE Mains? One thing I would tell you is focus on the areas that you are strong at. Try to increase your scores there. But also ensure that you are giving roughly equal time for all the 3 sections. It should not happen that in the area of your strength, you are spending too much time, because that I don't think will be the most optimal way of using time. We have 3 hours for attempting 75 questions. If say you are very strong at maths, maybe give 10 minutes more in maths and 5 minutes less in physics and chemistry. Similarly, if you are weak in any particular topic, maybe give slightly lesser time there. But it should not happen that out of the 3 hours, you are giving say 2 hours in one particular section and just half an hour to the remaining 2 sections. That I don't think will be a good use of time. Tarun Rai Varpu, yes, you are correct, Tarun. You got the right answer. Guys, please do like the stream. Okay, let us try to answer this question. In this question, we are told that let n be the number obtained on rolling a fair dice. If the probability that the system x minus ny plus z is equal to 6, x plus n minus 2y plus n plus 1 into z is equal to 8, and n minus 1 into y plus z is equal to 1 has a unique solution is k by 6, then the sum of all the values of n and the value of k is what we are required to calculate. If you are given a system of 3 equations, this will have a unique solution if the determinant of the coefficients of x, y and z are if the determinants of the coefficients of x, y and z are is not equal to 0. For example, in this particular case, what is the determinant of the coefficient matrix? It will be the coefficients of x, which is 1 over here. This also is 1. And in the third equation, we don't have a coefficient of x, so that is 0. What is the coefficient of y? It is minus n. Then we have n minus 2. And we have n minus 1. What are the coefficients of z? It is 1, n plus 1, and 1. This is the coefficient matrix. For this system of linear equations to have no solution, this coefficient matrix should have, the determinant of this coefficient matrix should be not equal to 0. And when is it not equal to 0? It is not equal to 0 when you are going to get n1 into n minus 2 minus n square minus 1. So this is minus n square plus 1 minus of minus n. So this is plus n into 1 plus 1 into n minus 1. This should not be equal to 0. If you are simplifying it, this is n minus 2 minus n square plus 1 plus n minus 1. This should not be equal to 0. We can cancel both of them. This is minus n square plus 3n minus 2 is not equal to 0. Now, when does this happen? When if you are simplifying it, this is n minus 1 into n minus 2 is not equal to 0. So the value of n should not be 1 or the value of n should not be 2. That is when this system has a unique solution. Now, what are the values that n can take? N is basically the number obtained on rolling a fair die. So the value that n can take, because it is the number obtained by rolling a fair die, it is either 1 or 2 or 3 or 4 or 5 or 6. But because the determinant should not be equal to 0, n cannot be equal to 1 or 2. So these two values are not possible. So n can take 4 values, 3 or 4 or 5 or 6. So the value of k is 4 by 6. Sorry, the value of k by 6, which is the probability that is given over here, is 4 by 6, or the value of k is equal to 4. The sum of all the possible values of n is 3 plus 4 plus 5 plus 6, which is equal to 18. You add 18 plus 4, you will get all the sum of all the values of n and k, which is equal to 22, which is option D. Let us look at the next question. Yeah, Shankar got it correct and Bhaskar also got it correct. Well done, guys. Reena Singh, I think you are right. Let us try to solve it and then we will confirm. But I think your answer is correct. Okay. In this question, we are given a system of linear equations. Now, if you're looking at the options are when does it have a unique solution and when does it have infinite solutions. Once you are given this system of linear equations, calculate the determinant of the coefficient matrix. What is the determinant of the coefficient matrix? If you're looking at the coefficient matrix, it is the columns will be the coefficient of x, which is 1, 2 and 1. Then the second column will be the coefficient of y, which is 1, 5 and 2. And the third column will be the coefficient of z, which is 1, a and 3. Now, if this determinant is not equal to 0, then this will have a unique solution. If this determinant is equal to 0, there are two cases possible. Either it has infinite solutions or it has no solution. So let us first calculate the value of the determinant. If this is not equal to 0, this has a unique solution. So what is the determinant? It is 15 minus 2a minus 1 into 6 minus a plus 1 into 4 minus 5, which is minus 1. This should not be equal to 0 for this system to have a unique solution. This is 15 minus 2a minus 6 plus a minus 1 should not be equal to 0 for this to have a unique solution. This is, if you are looking 6, 36 and b. The second column will be the coefficients of y, which is 1, 5 and 2. The third column will be the coefficients of z, which is 1, a and 3. If this is equal to 0, we can have infinite solutions. But this should be in addition to the original determinant being equal to 0. So in this case, a has to be equal to 8. So if you are simplifying this determinant, this will be 6, 36, b, 1, 5, 2, 1, 8 and 3. This has to be equal to 0. So you can simplify this as 6 times 15 minus 16, which is minus 1, minus 1 times 36 into 3 is 108, minus 8b, plus 1 times 36 into 2 is 72 minus 5b. This has to be equal to 0 for infinite solutions. So this is minus 6, minus 108, plus 8b, plus 72, minus 5b has to be equal to 0 for infinite solutions. Or 3b has to be equal to 42 for infinite solutions, or b has to be equal to 14. So the answer for this question is that it will have infinite solutions if a is equal to 0 and b is equal to 14, which is option D, like Reena mentioned. Let us look at the next question. Tarun Driver also said D. Correct, Tarun. Well done. ఏమండి వాళ్ళిద్దరు మాట్లాడదని చెప్పా, నాకు డిస్టర్బెన్స్ ఉంది. भैया क्लास चल रहा है, थोड़ा बात मत करो. ओके ना? ओके चलो. Okay. In this question, we are given a system of equations. This has 3 equations, and we are required to calculate when this has no solution. First, write down the determinant of the coefficient matrix. That is, write down all the 3 coefficients: the coefficient of x in the first column, coefficients of y in the second column, and coefficients of z in the third column. This system will have no solution. For that, we need to have 2 conditions. The first condition is the determinant of the coefficient matrix has to be equal to 0. So let us first write that down. What is the coefficient matrix? This will be the coefficient of x is 1 in the first case. It will be 1 in the second case, and it is 1 in the third case. The coefficient of y in the first one is 1, coefficient of y in the second one is 2, coefficient of y in the third one is 5. What about the coefficient of z? In the first one it is 1, in the second one it is 5, and in the third one it is lambda. Now, for this to have no solution, the first condition that should be satisfied is that the determinant of this coefficient matrix should be equal to 0. So if you are writing it down over here, this would imply that 2 lambda minus 25 minus 1 into, this is lambda minus 5 plus 1 into 5 minus 2, which is 3, has to be equal to 0. If you are simplifying this, this is 2 lambda minus 25 minus lambda plus 5 plus 3 has to be equal to 0. Or if you are simplifying it, this would imply that lambda has to be equal to 17. So the first condition that should be satisfied for this system of linear equations to have no solution is that lambda has to be equal to 17. If you're looking at the options, it is not option A, it is not option B, it has to be either option C or it has to be option D. In both the cases, lambda is equal to 17. The next condition that is given in both the options is mu is not equal to 18 or mu is equal to 18. Now, once you know that the determinant of the coefficient matrix is equal to 0, there are 2 cases that are possible. Either the system of linear equations has no solution or the system of linear equations has infinite solution. When does the system of linear equations have no solution? It will have no solution if one of d1, d2 or d3 is not equal to 0. What is d1? In the coefficient matrix, you just substitute one column with the constant terms. That is, for example, if you are looking at d1, you substitute the first column of the coefficient matrix. The second column and the third column will remain the same. What is the second column? It is 1, 2, 5. And what is the third column? It is 1, 5 lambda, which is 1, 5, and the value of lambda is 17. And instead of the coefficient of x, which are in the first column, in d1, you substitute the constant terms. What are the constant terms? It is 6, 9, and mu. This should not be equal to 0 for unique solution. Sorry, for no solution. If you are now simplifying it, you are going to get 6 times. 2 into 17 is 34, minus 25 is 9, minus 1 time, 17 into 9 is 153, minus 5 mu, plus 1 into 9 into 5 is 45, minus 2 mu. This should not be equal to 0. If you are simplifying it, this is 54 minus 153 plus 5 mu plus 45 minus 2 mu should not be equal to 0. 54 plus 45 is 99. 99 minus 153 is minus 54. Minus 54 plus 3 mu should not be equal to 0, or 3 mu should not be equal to 54, or mu should not be equal to 18 for no solution. So what are the two conditions that are needed for no solution? Lambda should be equal to 17 and mu should not be equal to 18, which is option C. This will be the correct answer. Let us look at the next question. One other thing I wanted to tell you is hundreds of students are downloading the Cracku formula PDFs for JEE mains on a daily basis. We have excellent formulas for all the three subjects, for physics, chemistry and maths. If you Google search Cracku JEE formulas PDF, you will get this page. And in this page, there are three PDFs. One is a comprehensive formulas for physics, that is a booklet. Another one is JEE mains chemistry formulas. The third one is JEE maths main formulas. If you download it, you will get access to the PDF like this. If you can see it, there are around 170 pages in this physics formula PDF. Similarly, for chemistry and maths, we have the PDFs which are very comprehensive and very extensive. I think these formulas are a very good way in which you can practice for the last few days in the run-up to JEE mains. So definitely do check them out. You can access them by just searching on Google Cracku JEE formulas PDF. Let us look at the next question now. Yeah, Tarun Raivarpu got it correct and Shankar Sahaj also got it correct. Well done, guys. Okay, let us try to answer this question. In this question, we are given a system of equations and we are told that this system has infinite solutions. What is the value of mu minus 2 lambda? Now we have looked at multiple cases where we first wrote down the coefficient matrix, then we calculated its determinant and then so on. There is another way to solve this kind of questions. The reason I included this question is to give a different way of solving it. If you have three equations, what are the three equations? One is 2x minus y plus z is equal to 4. The second one is 5x plus lambda y plus 3z is equal to 12. And the third one is 100x minus 47y plus mu z is equal to 212. When does this system have infinite solutions? This system of linear equations has infinite solutions if you multiply the first linear equation with some number and you multiply the second linear equation with some number, you add both of them and you're getting the third number. In that kind of a situation, this system of linear equations will have infinite solutions. Because we are essentially saying that the third equation is redundant. Whatever information is there in the third equation, we can get it by just transforming the first and the second equations. If you are combining them by multiplying them with some constants, we are getting the third equation. Then we are essentially saying that the third equation is redundant. We essentially have only two equations and three variables. So this system has infinite solutions. Let us try to calculate the value of a and b. If you are multiplying the first equation with a and the second equation with b, what is the coefficient of x? The coefficient of x will be 2a plus 5b. 2a plus 5b will be equal to 100. What is the constant term? The constant term will be 4a plus 12b, that will be equal to 212. What will be the coefficient of y? In the first equation, the coefficient of y is -1. -1 into a is minus a plus lambda into b is the coefficient of y, that is equal to -47. What is the coefficient of z? It is 1 into a plus 3 into b. This is equal to mu. Here we have two equations, both of them are in a and b. We can solve them to get the value of a and b. For example, if you divide this equation with 2, we are going to get 2a plus 6b is equal to 106. 2a plus 5 is 100, 2a plus 6b is 106. If you subtract one equation from the other, we are going to get that b is equal to 6. If b is equal to 6 and we substitute it in one of the two equations, 2a plus 30 is 100, or the value of a is 35. If b is 6 and a is 35, a plus 3b will be equal to 53. So mu is equal to 53. In the first equation, minus a is minus 35 plus 6 lambda is equal to minus 47, or the value of lambda is equal to minus 2. So the value of mu minus 2 lambda will be 53 plus 4, which is equal to 57. So the answer for this particular question is option A, which is 57. Let us look at the next question. Now we are going to look at some questions in number systems. Hi Pratyush, how are you? KRCKU9. Okay. Yes, Shankar and Tarun, the answer is correct. You both gave it as option A, which is 57. Well done. Okay, let us try to answer this question. In this question, we are asked to calculate the remainder when 3 to the power 2002 is divided by 5. Now 3 to the power 2022 is 9 to the power 1011. Now what is the remainder when 9 is divided by 5? When 9 is divided by 5, the remainder is 4. Another way of writing 4 is that when 9 is divided by 5, the remainder is minus 1. Because 4 minus 5 is equal to minus 1. So the remainder when 9 to the power 1011 is divided by 5 will be the same as minus 1 to the power 1011 divided by 5. Now what is minus 1 to the power 1011? It is minus 1. So the remainder when 9 to the power 1011 is divided by 5 is equal to minus 1, which is essentially equal to 4. So the answer for this question is option D. This is a fairly simple and straightforward question. This has actually come in JEE mains, January 2026. So you can expect some easy questions to come in JEE. This is the next question. Okay, Tarun Driverpu again got it correct. Shankar has also got it correct. Hi Dev Muradia. Is this relevant for JEE Advanced? I don't think this is relevant for JEE Advanced. This is relevant for JEE Mains. I think in JEE Advanced you won't get questions which are on the easier side like this. Hi Shlok Dwivedi. All the guys who have just joined, please do like the stream, guys. Dev Muradi is saying, I got 99.76 in Jan. Very well done, Dev. I hope you are preparing well for advanced. Okay, cool. All the best, Dev. We will actually upload a lot of videos for JEE Advanced also in the coming days. Because JEE Mains is coming, we are first uploading some videos for JEE Mains. But after that, we plan to upload a lot of videos for JEE Advanced. Okay, let us try to answer this question. The number of integers between 100 and 1000 having sum of their digits equal to 14 is. So we are looking for 3-digit numbers. Let the 3 digits be A, B and C. The sum of A plus B plus C is equal to 14. And what is the restriction on A, B and C? The restriction on A, B and C is that first A has to be greater than or equal to 1. A cannot be equal to 0. B and C can be 0. B, C are greater than or equal to 0. The second restriction is that all of them have to be single digit numbers. They cannot be 11 or 12 or 14. So A, B and C have to be less than or equal to 9. These are the restrictions and we are required to calculate how many solutions exist for this particular equation. Now, if you are ignoring this condition that all of them have to be single digit numbers, because A is greater than or equal to 1, let A1 be equal to A minus 1, or let the value of A be A1 plus 1. Now this equation, if you are substituting it, we are going to get A1 plus B plus C is equal to 13. And how many solutions does this equation have? The number of solutions this equation has will be 13 plus 3 minus 1 C 3 minus 1, which is equal to 15 C2, which is equal to 105. How do you know the answer for this? Because we know the formula for the number of non-negative integral solutions for a given equation. That is, if you are given an equation which is of the form x1 plus x2 plus dot 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 till xr is equal to 1 is equal to n, and you are told that all of these variables are integers which are greater than or equal to 0. The number of solutions for this will be n plus r minus 1 c r minus 1. In this particular case, there are 3 variables a1, b and c. They are equal to 13. So the number of solutions for that will be 13 plus 3 minus 1 c 3 minus 1, which is 105. But over here, we are going to get some more solutions which should not be applicable. For example, some of the solutions can be that, okay, one of them can be say 10 and 2 and 1. We know that any of the numbers cannot be equal to 10, but those will be considered in these 105 solutions. So we have to figure out how many solutions are there such that some of them, or say one of them, is actually greater than 9. Now again, if you are thinking about it, A, B and C, they have to be less than or equal to 9, or A1 has to be less than or equal to 8, B has to be less than or equal to 9, C has to be less than or equal to 9. These are things that should be satisfied. Let us calculate the number of solutions for which A1 is greater than 8. So let A2 be there, which is A1 minus 8. And let A2 be non-negative. If you are substituting that in this particular equation, where you are saying that A1 is equal to A2 plus 8, then we are essentially going to get A2 plus B plus C is equal to 5. Now, how many solutions does this equation have? Because we want it to be actually greater than 8, we will write A2 to be A1 minus 9, or A1 will be A2 plus 9. So if you are writing this equation, A1 plus B plus C is equal to 13, it will become equal to A2 plus B plus C is equal to 4. This will have 4 plus 3 minus 1, C 3 minus 1. This is 6C2, which is equal to 15. So we will have 15 solutions where the value of A is greater than or equal to 10. How many cases exist where b is greater than 9? If b is greater than 9, let us assume that b is equal to b1 plus 10 for some non-negative integer b1. So now the given equation we have, which is a1 plus b plus c is equal to 13, will get transformed to equal a1 plus b1 plus c is equal to 3. And how many solutions exist for it? The number of solutions will be 3 plus 3 minus 1, c3 minus 1, which is 5c2, which is equal to 10 solutions. So in 10 cases, the value of b is greater than or equal to 10. Similarly, let us look at the third case where c is greater than 9. If c is greater than 9, let us assume that there is a variable c1, which is c minus 10, or the value of c is c1 plus 10. So the given equation will be equal to a1 plus b plus c1 is equal to 3. Again, this will have 3 plus 3 minus 1, c3 minus 1 solutions, which is 5c2, which is equal to 10 solutions. So what we are essentially saying is that without any restriction on a, b and c, that is if they can be greater than or equal to 10, we are going to have 105 solutions. But out of these 105 solutions, in 15 solutions, a will be greater than or equal to 10. B will be greater than or equal to 10 in 10, and C will be greater than or equal to 10 in 10. These are solutions that should be removed. So the only valid number of solutions will be 105 minus 15 minus 10 minus 10. This will come to equal 70 solutions. So the answer for this particular question will be equal to 70. Let us look at the next question. Okay, let us try to solve this question. In this question, we are given that the sum of all the elements of the set 1, 2, dot, dot, dot till 100, such that the HCF of that number and 24 is 1 has to be calculated. What is 24? If you are doing the prime factorization of 24, this is 2 cube into 3. So any number which is a multiple of 2 or a multiple of 3, the HCF of that number and 24 will not be equal to 1. So if you are looking for HCF of alpha and 24 to be equal to 1, we are essentially looking for numbers which are not multiples of 2 and not multiples of 3. Let us first calculate the sum of all the numbers. Sum of all the numbers between 1 to 100, which is 1 plus 2 plus dot 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 till 100, is equal to 100 into 101 divided by 2. This is 5050. We know the formula for the sum of the first n natural numbers, that is 1 plus 2 plus dot 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 till n is equal to n into n plus 1 divided by 2. Here the value of n is equal to 100, so the sum of the first 100 natural numbers will be 100 into 101 divided by 2, which is 5050. Out of this, what is the sum of two multiples, that is all the multiples of 2? That will be 2 plus 4 plus 6 plus dot 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 till 100. This is equal to 2 times 1 plus 2 plus 3 plus dot 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 till 50. This again is the sum of the first 50 natural numbers. and that will be equal to 2 into 50 into 51 divided by 2, which is 50 into 51. This is equal to 2550. What is the sum of all the three multiples? The sum of all the three multiples will be 3 plus 6 plus 9 plus ... till 99. This is 3 into 1 plus 2 plus ... till 33. What is the sum of the first 33 natural numbers? Again, we can apply the same formula, which is n into n plus 1 by 2. This is 3 into 33 into 34 divided by 2. This is 17. So this is basically equal to 99 into 17, which is 1683. This is basically 1700 minus 17. But one thing you should notice is there will be some numbers which are common to both of these sets. There are some numbers which are both in multiples of 2 as well as in multiples of 3. They are the multiples of 6. So multiples of 6 will be double counted, because if you see, we have a 6 here and we have a 6 here. And because the multiples of 6 are double counted, we have to remove them. So what is the sum of 6 multiples? Sum of 6 multiples will be 6 plus 12 plus 18 plus ... till 96. Which if you take 6 common, it will be 1 plus 2 plus ... till 16. This is equal to 6 into 16 into 17 divided by 2. This is 18. Sorry, this is 8. This is equal to 48 into 17. What is 48 into 17? This is 850 minus 34, which is equal to 816. This has to be subtracted. So if you are looking for only the numbers which are multiples of either 2 or 3, that will be 2550, which is multiples of 2, plus 1683, which is multiples of 3, minus 816, which is multiples of both. If you are adding these two, it will be 4233 minus 816. This will be 7, and this is 1 and 4 and 3. So 3417 will be the sum of all the numbers which are either multiples of 2 or that of 3. So the the sum of all the numbers which are neither multiples of 2 or 3 between 1 to 100 is 5050 minus 3417. This will be equal to 1633. That will be the answer. Let us look at the next question. We also have an excellent question bank. All of them have detailed solutions, and these are being again attempted by hundreds of students every day. You have to either look at the link is given in the description, or you have to just Google search Cracku . Just Google Cracku JEE question bank. If you do that, you will get this question bank, which has more than 10,000 questions, around 3,500 in maths, 3,000 in physics, and I think 3,000 in chemistry. All of them with excellent explanations. Definitely do check them out. This is the next question, guys. Try to solve it. Okay. In this question, we are asked to calculate the remainder when 2021 to the power 2023 is divided by 7. Now, what is the remainder when 2021 is divided by 17? Is this 17 or 7? It is 7. Okay, what is the remainder when 2021 is divided by 7? The closest remainder, the closest multiple of 7 is 2016, which is 2100 minus 84. 84 is a multiple of 7, 2100 is also a multiple of 7. So the closest number which is a multiple of 7 which is less than 2021 is 2016. So 2021 is 5 times, so 2021 is 5 mod of 7. That is the remainder when 2021 is divided by 7 is 5. Now if you are looking at the powers of 5, we have 5, 25 and finally we have 125, which is 126 minus 1. 126 is a multiple of 7. So 5 cube leaves a remainder of minus 1 when divided by 7. What are we required to calculate here? We are required to calculate the remainder when 2021 to the power 2023 is divided by 7. Because 2021 is 5 mod 7, 2021 to the power 2023 is 5 to the power 2023 mod 7. Now 5 to the power 3 is equal to minus 1 mod 7. So if you are writing 5 to the power 2023 as 5 to the power 2022 into 5, 2022 basically is 5 to the power 3 whole to the power 674 into 5. Because 3 into 674 is 2022. Now 5 cube is minus 1 mod 7. So 5 to the power 2022 will be 1 mod 7. Because you are raising minus 1 to the power of 674. So minus 1 to the power 674 is 1. So 5 to the power 2022 is 1 mod 7. So 5 to the power 2023 is 5 mod 7. So the remainder when 5 to the power 2023 is divided by 7 is 5, which is option D. Let us look at the next question. Yes, Tarun, you are correct. The correct answer is 5. Okay, let us try to solve this question. In this question, we are required to calculate the total number of 3-digit numbers whose greatest common divisor with 36 is 2. So we want the highest common factor of this number and 36 to be equal to 2. So what is the type of number that it should be? So n, if you're looking at that number as n, this cannot be of the form 36k, that is, this cannot be a multiple of 36 because then the HCF will be equal to 36. This can be 36k plus 2 because the highest common factor of this number and 36 will be 2. Can this be of the form 36k plus 4? 36k plus 4 and 36, the highest common factor will be 4. It will not be 2. So it cannot be of the form 36k plus 4. Can it be of the form 36k plus 6? The highest common factor of 36k plus 6 and 36 will be equal to 6. It will not be equal to 2. So it cannot be of the form 36k plus 6. Can it be of the form 36k plus 8? 36k plus 8 and 36, the highest common factor will be 4 because 4 is a multiple, because 4 is a factor of 36k, 4 is a factor of 8 and 4 is a factor of 36. What about 36k plus 10? The highest common factor of 36k plus 10 and 36 will be equal to 2. Similarly, if you are looking at the next one, it will not be 12, it will be 14. So 36k plus 14. It will not be 16 because 16 and 36, the highest common factor is 4. It will not be 18 because highest common factor of 18 and 36 will be 18. It will not be 20 because 20 and 36, the highest common factor is 4. It can be 22. It cannot be 24 because 24 and 36, the highest common factor is 4. No, yeah, it is, I think 12, yeah. It can be 26, so 36k plus 26. It cannot be 28 or 30 or 32, it can be 34. So if you're looking at a particular number which is leaving a remainder or which is leaving a highest common factor of that number and 36 to be equal to 2, that number should leave a remainder of either 2, 10, 14, 22, 26 or 34 when divided by 36. And we are looking only for 3-digit numbers. If you're looking at the 3-digit numbers, they have to be first of all even because the highest common factor is 2. So this particular number also is even. 102 is a multiple of 6. The highest common factor of 102 and 108 will be 6. The highest common factor of 104 and 108 will be 4. Both of them are multiples of 4. The highest common factor of 106 and 108 will be 2. So the first 3-digit number which leaves a remainder of for which the highest common factor between that number and 108 is 2 will be 106. After that we are going to get 108, which is 36 into 3. This is the smallest 3-digit multiple of 36. What is the largest 3-digit multiple of 36? The largest 3-digit multiple of 36 is 36 into 27, which is 972. So when k is equal to 3, we are going to get 1, 2, 3, 4, 5 and 6. 6 numbers. These 6 numbers will be 108 plus 2, 108 plus 10, 108 plus 14, 108 plus 22, 108 plus 26, 108 plus 34. Then we are going to get k to be equal to 4. When k is equal to 4, again we are going to get 6 numbers. When k is equal to 4, 36k will be 144. So the numbers will be 144 plus 2, 144 plus 10, 144 plus 14, 144 plus 22, 144 plus 26, 144 plus 34 and so on. The values that k can take will be 3, 4, 5, ... till 27. The values that k can take because will be when k is 3, we are going to get 6 numbers. When k is 4, we get 6 numbers. And this will continue till when k is equal to 6. When k is equal to 6, again we are going to get 6. When k is equal to 26, we are going to get 6 numbers. But when k is equal to 27, we won't get 6 numbers, we will only get 5 numbers. Because 36 into 27 is 972. 972 plus 2 will leave the HCF will be 2. 972 plus 10, 972 plus 14, 22 and 26. All of that is fine, but for 97, 972 plus 34, this particular instance, it will be a 4-digit number. It will be greater than 1000. So in that particular case, we are only going to get 5 numbers. So the total numbers will be 106 is one number. Here we have 24 into 6 and here we have 5. So the total numbers will be 1 plus 144 plus 5, which is equal to 150. So the number of 3-digit numbers for which the greatest common divisor with 36 is 2 is 150. No, Tarun Driver, it is not 143, it is actually 150. So basically, I'll again explain to you. You have 106. You have 106, which is the smallest 3-digit number, which leaves a HCF of 2 when divided by 36, or between 36 and that number. After that, in every cycle between 108 and 144, which are both multiples of 36, we are going to get 6 numbers. Between 144 and 180, we are going to get 6 numbers. Between 180 and 216, we are going to get 6 numbers. This will continue till between 936 and 972. Here also we are going to get 6 numbers. These cycles are 24 into 6, which is 144. The next cycle of 972 to 1008, we will get 6 numbers, but one of those numbers will be greater than 1000. That number will be 1006. So in this cycle, we will only get 5 numbers. So what we are essentially saying is that 106 is one number plus 144 plus 5, this is 150 in total. Okay, let us try to solve this question. In this question, we are asked to calculate when 2021 to the power 3762 is divided by 17, what is the remainder? Let us first calculate the remainder when 2021 is divided by 17. 2021 is 1700 plus 321. This is 1700 plus 289 plus 32, which is 1700 plus 289 plus 17 plus 15. This is a multiple of 17, this is a multiple of 17, this is a multiple of 17. This is the only number which is not a multiple of 17. So when 2021 is divided by 17, the remainder is 15. Another way to write it is, this is minus 2 mod 17. Because 15 minus 17 is minus 2. We are required to calculate the remainder when 2021 to the power 3762 is divided by 17. Now 2021 is minus 2 mod 17. When you are raising it to 3762, the remainder will be minus 2 to the power 3762 when divided by 17. This is minus 2 to the power 3762, which is an even number. So that will be the same as the remainder when 2 to the power 3762 is divided by 17. Now we know that 2 to the power 4 is 16, which is minus 1 mod 17. So this 2 to the power 3762, we'll just write it as 2 to the power 3760 into 2 square. Why are we writing it? Because 3760 is a multiple of 4. So this is 2 to the power 4 whole to the power 940 into 2 square. Now 2 to the power 4 when divided by 17, the remainder is minus 1. So the whole remainder is equal to minus 1 to the power 940 into 2 square. This will be equal to 1 and 2 square is equal to 4. So the overall remainder when 2021 to the power 3762 is divided by 17 will be equal to 4. Let us look at the next question. Okay, let us try to answer this question. In this question, we are asked to calculate the number of two-digit numbers n such that 3 to the power n plus 7 to the power n is a multiple of 10. Now, if you are looking at 3 to the power n, the last digit will be in a cyclic order. What do I mean by it? If n is of the form 4k plus 1, that is, if it is leaving a remainder of 1 when divided by 4, the last digit of 3 to the power n will be 3. For example, if you see 3 to the power 1, the last digit is 3. 3 square, if you look at it, the last digit is 9. 3 cube, the last digit is 7. 3 to the power 4, the last digit is 1. And again the cycle repeats. 3 to the power 5, the last digit will be equal to 3. 3 to the power 6, the last digit will be 9, and so on. So, the last digit when n is of the form 4k plus 1, the last digit will be 3. If it is 4k plus 2, the last digit is 9. 4k plus 3, the last digit will be equal to 7. 4k plus 4, the last digit is 1. This is for 3 to the power n. Similarly, for 7 to the power n also, there is a cyclicity. 7 to the power 1, the last digit is 7. 7 square, the last digit is 9. 7 cube, the last digit is 3. 7 to the power 4, the last digit is 1. And again the cycle repeats. For 7 to the power 5, again the last digit is 7, and so on. So for 7 to the power n, when n is of the form 4k plus 1, the last digit is 7. Next we are going to get 9, then 3, and then 1. Now if you are adding both of them, the last digit will be 0. If you are adding both of them, the last digit will be 8. If you are adding both of them, the last digit will be 0. If you are adding both of them, the last digit will be 2. So the last digit will be 0 in this case and in this case. So whenever n is odd, (3 to the power n plus 7 to the power n is a multiple of 10. And we are looking for all the two-digit numbers. How many two-digit numbers are odd? We are going to get 11, 13, 15, till 99. These are 45 odd numbers. So the answer for this particular question is 45.